It's me again, Hector Nkosi. I'll be taking you for mathematics. Today we'll be looking at the different chapter of which is analytical geometry. Remember guys, if you've got any questions, you can always email me at nkosihector28@gmail.com. So as I was saying earlier on, we'll be looking at analytical geometry. I've organized a question that we can look at, the question that will help us to understand and grasp more concept when it comes to analytical geometry. I hope you are well, guys. I just need to greet you all. I can see the usual people are here. Alwande, Amanda, Anke. Okay, Asemahle Ben, Blessing Butle, Kalam, Dilo. Okay, Kamogelo Cat, Kaylee, Letabo, Lokshin Deep, Miss P, Monica, Nelly, Oli, Palisa, Sihle. Hello guys. Siposetu, Tabiso, Talita, Cherish, Trice, okay, Makwanya, Wandile. Okay, good afternoon, guys. Afternoon, everyone. Thank you so much for tuning in. Okay, we are about to start about today, guys. Okay, about today's work. And I hope you are well, guys. Okay, cool. That's perfect. Okay, today we'll be looking at 2018 paper 2, question 2, right? So with today's lesson, we'll be looking at analytical geometry as I was saying earlier on. Okay, cool. Just need to stop sharing and reshare again. Okay. All righty. Share screen. Perfect. Okay, cool. Now, guys, majority of you or all of you are familiar with the analytical geometry. Basically here, remember now in maths, you've got your analytical geometry and Euclidean geometry. But for the next 3 days or so, we'll be looking at analytical geometry, how to analyze shapes and stuff like that. And analytical geometry, guys, you need to be familiar with your formulas when we talk about your distance formula, your midpoint formula, your gradient formula, and your what you call the area of certain shapes, the area of a 2D and the area of the 3D shapes. So you need to be familiar with that. So here we are given the diagram that is presented here. This is from November DPE 2018, question 2, paper 2, right? So it says to you in the diagram below, this is the diagram, P 1 is to 0, which means the coordinates of P 1 is to 0 are these ones. Q 6 is to 3. This is Q 6 is to 3, right? And R 9 is to -2. That's R 9 is to -2, right? Vertices, which means we know what our vertices are. Vertices are the corners, guys, right, of a triangle. And we know that a triangle has 3 vertices, isn't it, guys? Because triangle has 3 sides, so it makes sense for it to have 3 vertices, right? Such as that PQ is equals to QR. So PQ is equals to QR, meaning now this and that, they are equal. Now, what do we know about a triangle that has 2 equal sides? Remember, we've got 3 types of triangles. We've got an isosceles, we've got a right angle triangle, we've got a scalene, right? So I'm giving you a homework to sort of identify or define all these three types of triangles that, for example, an isosceles triangle, what does it do? The right angle triangle, what does it do? And stuff like that, right? So you must go research that, guys. So we know that this and that they are equal, right? And Q, PQ, and um, QR, right, are what? You must also know this sign, guys. The sign that has a T. You know the T that is upper side, right? What does the sign stands for? I want everyone, guys, to tell me. I want everyone to tell me about the T that is facing downwards, right? I know that you know, but I want you guys, yes, perfect, perfect, perpendicular. That's perfect, guys. I'm so happy because you know your stuff, guys. And what do we know about something that is perpendicular? What do we know about something that is perpendicular? Right? Guys, what do we know about perpendicular lines? Yes, perfect. Yes, 90 degrees, the angles are equals to the angles equals to 180 degrees, 90 degrees, yes. So perpendicular, um, it means that the angles forms at the 90 degrees. Does it make sense? That's perfect. T is the point on PQ, right? Such that T is the midpoint of PQ. So T is the midpoint of PQ, right? S is the point of intersection of QR, right? So it's the intersection of QR, right? On the x-axis. V is the point on the x-axis. Where is V? Where is the V? V is the point on the x-axis. So basically, the x-axis are these ones. And here's V. Does it make sense, guys? And triangle Q, angle SV is equals to 121 degrees. And angle P is given by theta. Does it make sense? Here's angle P is given by theta. Perfect, guys. So now we've read all the statement here, right? Now I think we are ready to answer the questions, right? So here we'll be going step by step. Remember, guys, when you're doing your analytical geometry question, guys, you will always be given a shape or whatever shape in a Cartesian plane. So basically, you have to understand your Cartesian plane. What is your Cartesian plane? It's this diagram that has your y axis and your x axis. This is your Cartesian plane. So any shape that you are given, it can be written either on the left hand side or on the right hand side or at the upper side or at the downside. So you just need to know which side it is. Does it make sense, boys and girls? Then now I see some comments. Okay. Okay, cool. All right. Okay, cool. All right. I'm still analyzing the question. I'm still analyzing the diagram, guys. We haven't started with the questions. I can see other people, they are saying people are still trying to log in. I can see that, guys, but just know, bear in mind that we are doing analytical geometry. Analytical geometry, it's also part of term one's work, right? It's part of term one's work, guys. Okay, cool. Perfect. Right. Now, let's look at the questions. Now, question 2.1. It says determine the length of PQ. Leave your answer in set form. So where is the length of PQ? So here is P, here is Q. In order for you to calculate the length of PQ, you need the coordinates of P and you need the coordinates of Q. And yes, we do have the coordinates of P, 1 is to 0, the coordinates of Q, 6 is to 3. Now, the examiner is asking, what is the length from here to there, from P to Q, right? So you need to calculate the length. So in order for you to calculate the length, you need to know a distance formula. A distance formula now, guys, you have to know it by this time. Now, if you look at the solution, this is your distance formula. Now, PQ, your distance formula is given like this. You have to know it by now, guys. You have to know it from your formula sheet. So it says Q2, X2 minus X1 all squared plus Y squared minus Y1, Y2 minus Y1 all squared, right? Then you substitute the coordinates of P and you substitute the coordinates of Q. Remember when you start the coordinates, guys, where the coordinate starts, it's always X. So meaning now, this is X for P, the 1. For Q, this is X. 6 is Q for X. Does it make sense? Same applies. 0 is Y for P. 3 it's Y for Q, basically. Does it make sense? So this is how you calculate what? This is how you calculate your distance. Then you insect everything. Then you know 1 minus 6, it's 5 squared, and 5 squared is 25, right? Then negative 3 squared, it's 9. 29 plus 9, it's 34. And remember, the examiner told you that you must leave your answer in set form. Meaning now, because you don't have the square root of 34, you can leave your answer in a set form. That's what they mean. Okay, let me check at the comments. Okay, cool. Guys, those who have just joined, we are doing analytical geometry. Balisa M is asking, the formula is 2 squared. Is it 2 square root? What do you mean, Balisa, when you're saying is it 2 square root? Please elaborate, right? Okay. Yes, I can see Miss P. She's remembering now. Okay, cool. All right, cool. Guys, this is part of term one's work, right? Yes, you have to square root. Yes, that's the formula. The way it's given, you have to square root. The formula it's given as PQ is equals to open bracket x2 minus x1 all squared plus y2 minus y1 all squared. That's the formula it's given, right? Right, okay. We haven't started 2.1.2. We haven't started about that question. We're still going that, right? We're still going there, boys and girls. Okay, cool. Now, if we look at the gradient of PQ, now, the gradient of PQ now, also you need to know the formula. I love this chapter, guys, because it's very easy. You just need to know your formulas and you just need to understand them. Then you can do any workings, right? So they are looking for a gradient of PQ. So what is the gradient of PQ? Now, we know that the gradient formula it's given by this. We know that is my over x, but you need to say y2 over y1 over x2 minus x1, right? So all the y's, they must be your numerator. All the x's for both coordinates, they must be your denominator. So 3 less than 0 over 6 less than 1, right? Therefore, your gradient of PQ is 3 over 5. Does it make sense? And yes, it does make sense. The gradient that goes this side that goes upwards, always it must be positive. The gradient that goes downwards, of a line that goes downwards, must always be negative. So because now this gradient of ours is going upwards, so it makes sense for us to get a positive value. But if they were saying to you, calculate the gradient of PR, it was supposed to be a negative because your slope is going downwards. But because here the slope is going upwards, therefore the gradient must be positive, right? So that's another way to check your gradient, whether it's correct or not, right? Okay, okay, cool. Yes, Butle, you can simplify to a decimal number. You can simplify your gradient to a decimal number. Okay, cool. Right, that's perfect. Okay, now it says to you the coordinates of t. Now, if we look at the coordinates of t, we were told that it's a midpoint of PQ. Can you see t is here? And we're told that it's a what? It's a midpoint of PQ, right? So basically here, guys, you need to understand the midpoint of PQ. So when you calculate your midpoint, you need to know your midpoint formula by now, guys, right? You need to know your midpoint formula. So your xt is equals to x1 plus x2 over 2. Then your y, the other side, y1 plus y2 over 2. Therefore, you take your PQ coordinates, you substitute them here, and you have the coordinates of t. So the coordinates of t, as we said, is the midpoint. So here you are supposed to use the midpoint formula. So it's 7 over 2 is to 3 over 2. Does it make sense, boys and girls? Right. Perfect. Okay, cool. All right. Okay, okay, guys. So, okay, I can see other comment they're saying they don't understand this t, the coordinates of t. Basically, guys, the t, it's in the middle of P and Q, meaning now t is the midpoint of PQ. Therefore, you're supposed to do what? Supposed to use the coordinate, the formula of you must supposed to use the midpoint formula in order to get the coordinates of t. All right. Now, 2.2. 2.2.1, they are looking for the area of the triangle. Now, guys, this is very important. When you are calculating the area, guys, when you are calculating the area of the triangle now, guys, you have to know it by now. You've learned about the area and the perimeters formulas in grade 8 and grade 9. So you have to know it by head. It won't be given to you, the formula. So they can give you a square, they can give you a triangle, they can give you a circle, but circles, you are not covering them in grade 10. You're only going to start to cover them in grade 12 when you do circle geometry. But now the other shapes, you have to know their area. When they say to you calculate the area of the square, you need to know its formula. Same applies the area of a rectangle, the area of a parallelogram, the area of the rhombus, the area of a triangle, right? You must know. I know the area of a triangle. that is half times base times height, right? So that's the area of a triangle, half times base times height, right? So now, if you look here, before we look at the solution, because we're told that this is base and this is height, right? Or you can say this is your base and this will be your height. So it's just going to be half times base times height. So now, if you look here, that's what they did here. They said, okay, QR is equals to QP because we were told that QR is equals to QP. We were told here in the statement above, right? We were told here that a triangle such that PQ is equals to QR, right? So which means your base is equals to your height. Does it make sense? This will be your base and this will be your height. So if your base is equals to your height, which means if it's, for example, 5, even this side must be 5. Does it make sense? So now it's going to be easier for you to calculate your area of your triangle. Now, so you must show the marker that you understand what was happening above. So QR is equals to QP and is equals to square root of 34. Where did you take the square root of 34? It was the distance of QP, right? In 2.11, right? The square root of 34, right? It was the distance of QP. But because QP is equals to QR, which means QR is also given by the square root of 34. Therefore, you must do what? You must do the area of a triangle QTR. Let's look at the area of the QTR. So it's QTR, right? So QTR. So we're looking for this area of this triangle, not the whole entire triangle, not the QPR, but the QTR. Does it make sense, boys and girls? We know that T was the midpoint of P and Q, and we got its coordinates. Does it make sense, guys? All right. Now, so what we're supposed to do here, guys, you're supposed to say, okay, now, the area of the triangle, it's calculated like this: half times base times height. So the base will be QR, the height will be QT, right? Therefore, this is your half, and your base will be given as the root of 34. But now your height, it will be half of what was equals to this, of, because T, it's in the middle. So now, meaning now, this will be, your height will be what? It will be half of this. So no wonder we write half of square root 34, right? Therefore, your answer is 17 over 2. How did we get 17 over 2? It's half multiplied by root 34 multiplied by half multiplied by root 34. And we can also write it in what you call in decimals also, right? And you must write meters squared, right? Remember, the area of a 2D, it's always meters squared, right? Units squared, right? I see some other comments. I just want to check. Okay, cool. All right. Okay, I need to read the comments. Guys, you need to know the formulas, right? The formulas are in your textbooks. You need to know. I mean, if the examiner is lenient, they can always give it to you at the back of the question paper, right? But in most of the time, you just need to be familiar with your formulas, right? You just need to know them by heart. I can see Miss P says you must know them by heart, right? Sometimes other formulas are given, others are not given. So the best way is just to know all your formulas and not depend on whether the formulas are going to be given or not, right? Okay, someone else is asking, is there a better way to do that? Know them by heart is by practicing more. Remember, guys, maths is a continuous subject. You can't just do one sum or one question and expect to know everything, you know. Remember, guys, Rome was not built in one day, right? So the more you practice is the more you're going to be familiar with your work, is the more you're going to be familiar with your formulas also. But if you just do one sum and you just close the books, unfortunately, you're not going to be familiar with your formulas, right? Okay, I'm still reading at the comments. Okay. Poppy, not yet. Not yet. Maybe sometime next week. Um, are you? She's asking whether are we going to do similarities? Not yet. Not yet so far. Right. Okay. Yes, Miss Pish is right. That's perfect. Okay. Perfect. Okay. Yes, yes. Yes, Kush, practice makes perfect. Yes, that's perfect. Yes, yes. Actually, when you practice, it makes it perfect. So the more you practice is the more you're going to be familiar with your work, guys, right? Let's look at the next question. Perfect. Now, when you look at the next question now, it's 2 marks. It says the size of theta with reasons, right? So basically, they want the size of theta. Basically, they want to know what is the angle, this angle of theta, right? The angle theta, right? What is the size of it? And you must give a reason. So now let's look. Okay. Guys, as much as I would want to explain everything into detail, but remember we have limited time. We only have like 40 minutes, right? Perfect. Now, remember now, guys, the size of theta. Now, let's go back to our diagram. The size of theta, it's by uh, angle P, basically, right? And there we are given an outside angle of which is 1 to 1, of which is next to S. So when you look here, boys and girls, so your angle QSP is equals to 59, right? Meaning now your angle in a straight line. Does it make sense? Right. But most of the time, I don't like this working. I like the first one. The first one, theta is equals to 121. The angle that is outside minus the 90, right? It must give you 31. So the answer is 31, right? So this is what is the exterior angle triangle. Does it make sense? This is your reason. But as I was saying, guys, some of you could have preferred this method, but I prefer the first one. Excuse me, because this is straightforward and it's just straight to the answer, right? And remember, they said with reasons, so you're going to get 1 mark for a reason and 1 mark for the answer, right? Okay, cool. Yes. That's perfect, guys. That's perfect. That's perfect. Yes. Yes, Andrian, presentation, I think, yes. Perfect. Yes, that's perfect, guys. Okay. I know some of you are still copying here. You want to to copy the workings and stuff. But remember, these will also be uploaded on YouTube later on. So you can always look at your what you call at these videos. Now, let's look at the coordinates of S. Now, with the coordinates of S, the coordinates of S, it's this one. Because now S, it's in the X, it's in what? It's in your x-axis, which means y is 0, which means the coordinates of S is to 0. Because now the S is on the x-axis. Does it make sense? So basically here it means that y by default will be 0, but we need to find the x. But how can we get the x? Okay, cool. And how many marks is this? It's 3 marks, right? So there are so many ways you can do this one, boys and girls. There are so many ways you can do this one. Okay, I don't like this one because I haven't started trigonometry with you guys. Yes, this is correct. I know those who are familiar with the trigonometry maybe are saying, yes, we understand the cos theta, sin theta. I don't want to confuse you because you guys haven't started with trig yet. However, I love this method here. This method here, you just need to find the gradient of QR, of which is negative 5/3. Right. That's the gradient of QR. Then you substitute it with your X. I mean, you substituted to do, okay. So you substituted to your formula so that you can get the value of X. And the value of X is 7.8. Meaning now, why are we saying the gradient of QR is negative 5/3? This is the thing that I've explained earlier on. Remember, because these are perpendicular, right, guys? Now, we got the gradient here, right? And I said it's always going to be positive. And I said the downward sloping its gradient, it's always going to be negative. And we know that because this is equals to that, meaning their gradient, they are also equal. However, now this must be negative because it's going this way, downward sloping. This is, it was the upward sloping, right? If you look at question 2.1.2. So now if we go back to question 2.1.2, question 2.1.2, it was the gradient of PQ and we got 3/5, right? But now this was 3/5. This will be what? Negative 3/5 for QR. Does it make sense, boys and girls? Because now it's on the other side, right? I mean 5/3. Not 3/5, but 5/3. Remember now, if something is perpendicular to each other, you always multiply by -1, right? So it just swap, right? Whatever was the denominator, it becomes the numerator. Whatever was the numerator becomes a denominator. Then you multiply it by -1 because the sides are perpendicular. And the gradient of QR, it's -5/3. Therefore, you have to insert it to your formula of a gradient, right? But bear in mind that this one is the X that you are looking for. Therefore, X will be 7.8. So the coordinates of S, it will be 7.8 is to 0. These are the coordinates here. I hope it makes sense because we got the gradient of this side because we know that this is perpendicular to that. Okay, let me look at the comments. Okay, right. That's perfect. Right. Okay, cool. Okay, guys, remember trigonometry is part of term 2, right? Tino, I've been preaching that trigonometry is part of the term 2's work, right? We're still under term 1, right? Can you see, guys, there are a lot of things that you need to learn in terms 1's work, right? Tomorrow, before we start the lesson, I'll sort of put the annual teaching plan so that you can see what is the chapters that are in term 2, the chapters that are in term 1. We cannot go to term 2. Meanwhile, you guys are still not understanding your terms 1's work. Does it make sense? Because some of you are still confused with analytical geometry and we're still starting analytical geometry. Remember all along, the last 2 weeks, we were doing algebra. I was trying to make you understand, guys, the algebra. And you were comfortable with your algebra, you were understanding, right? So we can't just do one chapter and guess to be fine, right? In that chapter, we need to do lots and lots of questions. I hope I make sense, guys. Last question now. With this one, it says to you, determine with reasons the gradient of the line through T and the midpoint of PR. So the gradient of the line through T, the gradient of the line through T, right? And the midpoint of PR. So PR, right? The midpoint of PR and the gradient. So now, if you look this one, guys, let's look here. Okay, we are only left with a minute. It's fine, guys. This one, I'll try to explain it tomorrow because we are running out of time. Our time is almost over. Tomorrow, I will start to recap from 2.3. Yeah. But if you've got any questions, guys, please feel free to email me at nkosihector28@gmail.com. I'll be explaining to you step by step. But remember, tomorrow we're just going to recap where we finished off. Thank you so much, guys. Have a lovely day.